Yeah, good morning. In this session, I would like to demonstrate the use of a calculator block for solving a simple problem. In fact, without the use of a calculator block, we will not be able to handle this. Normally, in any block, we will be able to specify the block by means of a particular value, not an equation. In addition to this, because we are specifying the molar flow rate, until and unless we simulate, we will not be able to know what is the corresponding volumetric flow rate. This could be one issue. And moreover, the volumetric flow rate depends on the molar flow rate. And when you are changing the rate from 1 to 10, accordingly the volumetric flow rate changes and thereby the pressure drop changes and the exit pressure is also going to change. So this can be handled by using a calculator block. So let us try to see how to handle this problem with the use of a calculator block. So we have defined the component, then select a property model. So in case of water or steam, you can use steam tables as the property model. And in this example, as we are not interested in going into the design calculations, I am using a simple block heater, the input and output streams, then go to next and try to define the problem. So let me change the unit system to SI. So it is entering at, water is entering at 30 degrees centigrade, a pressure of 5 bar and with a flow rate of 1 kilomole per second. So we have defined the input stream. Now let us define the block. The outlet temperature is to be 50 degrees centigrade. Here we will not be able to define the pressure drop because the pressure drop is going to depend on the volumetric flow. We are not aware. So for the time being, let me presume that the pressure drop is 0. Okay, and we will try to address this issue by using a calculator block. So click on calculator, say new. Right. So the pressure drop or the exit pressure is going to depend on the volumetric flow rate. So I would like to read the volumetric flow rate from Aspen simulation into the calculator block. So this is a stream variable. Again, you can go to stream variable. Stream is input stream. Variable is volumetric flow in cubic meters per second. Then I would like to calculate the output pressure. Right? So this is block variable. I'm going to export this value. V1 variable is pressure. See, remember, though I am using this as a block variable, because whenever you want to calculate, that value must have been actually specified in your simulation as input. Some reference value must be available. If I say it as a stream variable, I will not be knowing the value of the stream variable to start with. That's why I'm taking it as a block variable for the time being. Now let me go to the next. Now, as you know, you can use either the Fortran or maybe Excel. Output pressure is equal to 5 minus, that is the inlet pressure, minus the pressure drop, which is given as 0.1 multiplied by Vf. So this is going to talk about the output pressure because this will be a positive value. So this will be taken as the output pressure or the pressure at which the block is operating. So having done this, let me run this problem. You can just see the stream summary. Now in this particular case, we had on the volumetric flow rate. Of course, you can see the results of this defined variable. Now the volumetric flow rate corresponding to 1 kilomole per second in terms of cubic meters per second is given this. So the pressure drop is 0.0018, 0.1 multiplied by V. So that's why the outlet pressure is 5 minus 0.0018. So it is coming to 4.998. Now, in addition to this, we would like to now make use of a sensitivity block, say new. Okay. What is the variable you would like to vary? So we wanted to vary the molar flow rate of the input, mole flow, because there is only one component. It doesn't matter whether you take mole flow or component flow, it doesn't matter. So starting point is 1, ending point is 10, maybe increment is 1. So this is how we are varying. What is that we would like to look at? Pressure. Let us say the outlet pressure. Pressure, it's a stream variable. Stream variable. Stream is outlet stream. Variable is pressure. So let us put this in bar. Next, tabulate. Simply say fill variables. Next. Now you can see the results of your sensitivity. So as the flow rate increases, the volumetric flow rate also is going to increase. That's why there is a slightly more pressure drop. So this is, of course, for each of these, the calculator block will be doing these calculations. So initially, of course, for the initial value, we know because it will not be tabulating all the required values. The final value is 4.98195 and this is the value written. So this way, we will be in a position to handle the calculations which are not possible within the block by use of a calculator block. So let me close this session here.